Good morning, everyone. Thank you for coming to my presentation. I will do my best wearing Irish green. So in this presentation, I will introduce our magic item, anti-debug seeker, which is open source tool I developed. Presentation title is automatically detect and support against anti-debug with IDAGhidra and Ghidra to streamline debugging process. So let me introduce myself briefly. I belong at the Cyber Emergency Center. Since 2016, I started work as a security analyst, Security Operations Center. Since 2017, I started analyze malware, and now mainly focus on responsible for malware analysis related to the cyber incident. Here is agenda for today. I will begin by exploring what is anti-debug seeker, providing an introduction to its core functionalities. Next, I will proceed to a demo using IDA version. Following that, I will move on to introduction configuration files, where I will cover the essential configuration aspects. A second demo will be conducted, this time showcasing the Ghidra version of anti-debug seeker. Afterward, I will dive into the file related to the Ghidra version. Finally, I will wrap up the session with a summary of the key points covered. First, what is anti-debug seeker? So this is a program for automatically identify and extract potential anti-debugging techniques used by malware and displaying them in IDA and Ghidra. The main functionalities of this plugin are as follows. Number one, extraction of APIs that are potentially being used for anti-debugging by the malware. Number two, in addition to the APIs, extraction of the anti-debugging techniques based on the key phrases that serve as triggers, as some anti-debugging method cannot be comprehensively identified by API call alone. So using multiple keywords, anti-debug techniques are extracted. Things to keep in mind when using these tools, for packed samples, running this plugin after unpacking and fixing the import address table is more effective. All right, let me show you an IDA version of anti-debug seeker. I use an unpacked version of RSNF. Flow of demo, number one, what type of anti-analyst leads to the termination of the process. Number two, using anti-debug seeker to find anti-analyst features. Number three, apply patch using a debugger. First, not patch version. I just execute our sniff. Once executed, the process ends due to some anti-analysis feature happens. So using IDA version of anti-debug seeker to find anti-analysis features. So load it into the IDA. So once loaded into the IDA, from output, we can confirm the message control plus shift D, shift start analysis. So if press them, anti-debug seeker starts. So processing logs are also displayed. If some code are detected by anti-debug seeker, we can confirm how many hits and the rule name we can check easily. If anti-debug seeker finished, display anti-debug detection result. I explain each column in a detail. First, category name, API category name defined in anti-debug API. Anti-debug API and anti-debug technique refer to the section in the rule files. I will explain more about it later. So number two, possible anti-debug API, list of detected APIs displays. Number three, address where the detected API is being used. Number four, possible anti-debug technique. Detection name identifies a keyword defining anti-debug technique. Finally, address of the first detected keyword. You can jump to the address by double-click address line. So what is detected by API trigger will have a green background. So these are APIs and check analysis environment. So this function is possible used for the anti-debugging. So I explain another tab, detected function list. So detected function list to display the result of the anti-debug detection result organized by each function. Each function would be listed with its corresponding detection result, making it easier to analyze and understand where and how anti-debugging techniques are implemented in the code. By hovering the cursor over a rule, it displays the reasons for the detection. This feature can also be used to determine false positives. In the anti-debug technique section, detected items are set up so that you can check the meaning of the rule like this. By understanding the detail of the rule, you can also gain the hints on how to address them. So this function I use for our anti-debugging. So if you want to debug this function, double-click this function name, display recursively where the function to be investigated is called. Depths represent from the original entry point. So this is depth 1, so depth 2. So the function in the detected function list that match the result are displayed in a gray. Hovering the cursor over, these functions will display the reasons why they were detected. So this case, we already checked this function, checked analysis environment. So this API is detected by anti-debug seeker. You can also easily check which APIs might be used for anti-debugging. Sorry. Okay. Yeah, this is check hardware API, so detected by anti-debug seeker. So another function will also detected by anti-debug seeker. So it is apparent that sub 40100 is called from sub 401571. So double click on the address in the code order. So jump to the 40113. So this is depth 1. So it's near, this is OEP. So this depth 1 is here. So the target function is depth 2. Okay, recheck. This is already we check, a nice environment check. So this function is anti-VM. So this conditional branch is really important. So if it doesn't go to the 401724, malware goes to the exit process. So we need to patch this area. So from this information, apply the patch with the debugger. So while checking the result of anti-debug seeker, so load it into the X32 debugger. So set the breakpoint at address displayed at depth 1. The breakpoint has been set, and press F9 as step into. Then set the breakpoint at depth 2. So now we are here. So jump to the 401724, the process will continue. So now it won't jump as it is because this is a VMware environment. So we needed to patch. Example answer is J to JMP. So this is a patch file. So prepare for the Wireshark. Execute it. So the process continues successfully, avoiding VM detection. So the Wireshark, we confirm the C2 destination. And also for TCP stream, we can check characteristic of RSNF communication. The analysis result of IDA anti-debug seeker. In the red square, it was determined that function sub40100 has anti-debugging features. In addition, yellow square, it also informed us about suspect aspect related to the malware function, such as memory manipulation. This tool can detect not only anti-debug features, but also malware techniques, such as process injection and similar method, depends on the custom rule files. So, introduction to configuration files. Here is an explanation of the files required to run IDA's anti-debug seeker. You will need three files run to the IDA version. Number one, anti-debug.config. A file contains the rules for detecting anti-debugging techniques. Number two, anti-debug techniques descriptions.json. A file contains descriptions of the detected rules. Number three, anti-debug seeker.py. This is a main program. So first, the anti-debug.config is divided two sections: the anti-debug API and anti-debug technique. So I explain anti-debug API section at first. In the anti-debug API section, you can freely create categories and any number of APIs you want to detect. But since this section requires an exact match, so please be careful, especially with case sensitivity. So next, I explain the anti-debug technique section. You can also create any number of categories. The number of keywords that can be assigned to a single category is limited to 3. The basic flow of the search is first, the search begins with the first keyword. If it is found, the second keyword is searched for within specified number of bytes. Default is 80 bytes. The same process is applied when searching for the third keyword. If you want to set a custom search range, instead of using a default value, you can specify the search range equal value at the end of keyword you have set. This allows you to change the search range for each rule you have configured. The search target include disassembly, OP code operand, comments, and API based on import table. These files contain the descriptions of all rules listed in anti-debug technique. The value defined in this file can be referenced on the disassembly screen, allowing you to check the detailed information of the rules. So next, I will show you a Ghidra version of anti-debug seeker. So I use an unpacked version of Kakbot. The flow of a demo, number one, type of anti-analysis leads to termination of the process. Number two, using anti-debug seeker to find anti-analysis features. 1 and 2 is the same process, demo 1. So finally, number 3, examine the behavior of anti-debug and identify the areas to patch from anti-debug seeker results. Plus, apply the patches using a debugger. Okay, first, not patch version. I just execute Kakbot. So Kakbot is executed with a /c argument, but it looks like running, but no communication occurs. So, using Ghidra anti-debug seeker to find anti-analysis features. So select the window anti-debug seeker.plugin. Click Start Analyze. So the pop-up here, so select config file is displayed. So specify anti-debug ghidra.config that defines the detection rules Then click Open. Next, select JSON file is displayed. So specify anti-debug technique descriptions ghidra.json, which contains the descriptions of detection rules. So anti-debug seeker start. Processing log are also displayed. Progress bar is here. You can check detection result from this window. If a progress bar reached 100%, a message come up. The analysis complete will be displayed. The detection result can be checked from GUI interface or bookmarks. Bookmarks I will explain later. So you can see the result, but display results include both detected and non-detected items. If you want to display only the detected items, press the middle button. Click display only the detection events. So we can focus on the detection events. Next, far right button. Group by function and display the organized result. It becomes easier for the user to understand from which function to start checking. So next, I explain bookmarks. So you can check the details result anti-debug seeker from bookmarks. Two types of categories, potential anti-debug API. This is API-based triggers. Number two, possible anti-debug technique. This is a key phrase trigger base. So first, anti-debug API. Items detected by anti-debug API will have green background color, and the rule name will be set as a pre-comment, like this. This is rule name. And in this case, time check and analyze environment check. So next, anti-debug technique. In this case, we have orange background color, and the rule name will be set as a pre-comment. This is the same as the anti-debug API. The different point is a post comment. The detailed information will be displayed as a post comment from the loaded JSON files. So you can check easily more detailed information from this information. So let's look at example rule for detecting create mutex. So this is rule listed in anti-debug technique section. Create mutex first keyword, get rust error here, get rust error here. So next 0xb7 here. So you can see where all keywords are being detected. Next, let's check environment timing check CPU ID detected by anti-debug technique. The CPU ID instruction can be used as part of malware's anti-analysis features. It's involved check for analyzed environment and timing check. Due to its high potential as an anti-analysis features, we will also examine our surrounding code. By performing a cross-reference. We can see multiple functions are linked together. In a highlighted yellow, the environment timing check, CPU ID. So let's look at other part as well. So we can check also VMware presence comment. So this indicates anti-debug seeker is detecting VM presence in this area. Check VMware. So next, check hardware. I don't have time to check everything, but this code indicates anti-debug process is being executed. So now let's take a look at one of the anti-debug techniques that were actually detected. So debug area is VM presence. Here. So load it into the X32 debugger. Running it with the /c argument triggers the anti-debug checks. So jump to the address where the VM check is happening and set breakpoint. Read data from the specified input-out port and compare it with the VMX to detect VMware. After executing the VMware check function, the code moved to the anti-debug related section we reviewed earlier. Since this environment is VM, so it skipped other anti-debugging checks and jump ahead. The process terminates with the exit process. Identify the area to patch from the anti-analyst wizard. So place a breakpoint on the get exit code process from the analyst wizard and run it. So by checking the return value of get exit code process, it verifies whether the child process run with /c started successfully. Since /c is for checking anti-debug, remove it from the parameter. Jump to get exit code process. So check get exit code process to detect if it's an analyst environment using create process W, the child process run with the /c parameter. If it's a process continue as it is, the return value in EX will become not 0 equal detected. Therefore, we will assign 0 to EX. Move EX 0. So this is patch file. Execute patch file. So different behavior compared to when patch is not applied. So executed for a while, we can see Kakbot C2 communication. The analysis result of IDAGhidra anti-debug seeker. So title, the total number of functions is 7, out of which 5 were detected. 2 functions were not detected, as it's difficult to detect things that are resolved dynamically. This is a weakness of the tools. However, the detection rate is approximately 70%, so if implemented in a static code, most cases can be detected. Introduction to file related to the IDAGhidra version. So the rule files, JSON file, and use both IDAGhidra script and IDAGhidra extension can be the same. These 2 files are similar to those in IDLE, but they are developed specifically for IDAGhidra. So for the IDAGhidra script, use anti-debug seeker.java, which is specifically developed for you can activate from script manager. IDAGhidra public anti-debug seeker.zip, it is necessary to integrate a precompiled folder into the IDAGhidra. Finally, I will wrap up this talk. This tool brings about 3 key benefits. First, by identifying the anti-debugging features of the malware and displaying the result clearly via the GUI interface, it improves the efficiency of analysis by grouping the result by function. Number 2, while detecting anti-debugging, it can also identify techniques used by malware, and you can freely and easily add any rules. Number 3, as a support features, you can recursively investigate the path to identify the anti-debugging, so further enhance debug efficiency. So thank you for presentation. This is IDAGhidra QR code and IDAGhidra version. So thank you very much for listening to my presentation. Thank you.
Thank you very much, Takahiro. Do you have any questions in the audience? Yes, raise your hand. One over there.
Hi.
Hi.
Have you considered some further improving of the plugin, like directly patching of the located anti-debugging features, like maybe using like IDA conditional breakpoints and other stuffs? Like for example, if you have like UI that is showing the detected anti-debug features, maybe there could be some context menu to directly patch it using, for example, in IDA Python with some conditional breakpoint and other stuffs. Like if you consider improvement of the plugin that can enable to directly patching the detected anti-debug features.
Directly patch. Sorry, this question is this plugin will develop a directory patch. Okay. So now we're focusing on only detection of the static code. So yeah, in the future work, I will try it.
And if I can also add a question, if you are familiar with Kappa Explorer, or like the plugin from Mandiant, that can also detect statically some features and also have some rules regarding anti-debug, if you consider to also maybe contribute to that project with your own, knowledge or rules regarding the static detection, no.
Yeah, so I like Kappa Explorer. So yes, if it's possible, if possible, I will contribute Kappa project. Yeah, and I also learn from Kappa rule. Yeah, so so this tool. So I think I believe Kappa Explorer provides insight not only anti-debugging but also overall functionality of malware. Yeah, so because of its advanced feature, I'm wanting to that it's more focused on anti-debugging in a similar way. So additionally, I wanted to flexibility to easily modify the rule to fit my preferences, which is why I developed these tools, and also aim to create something easy to understand for those who are just starting out with malware analysis.
Thank you.